energy transition, critical minerals and critical thinking. Everything starts with the rock.
Thank you. Yes, so it's been fantastic to hear a couple of like really researchy type talks, and now I'm going to go all superficial on you and back to my motto before of everything starts with the rock. And I was trying really hard to get a very, very long title, and actually want to put even more on there, because I wanted to also put the sentence on there, the question of why critical minerals are different, why they're not. So I will circle around a little bit those 4 questions, those 3 and the one that didn't really make it on there. The energy transition, what does critical minerals mean to it? How are they different? How aren't they different? And how is geoscience important? And perhaps also where is geoscience less important? And this, of course, is just really summarizing why minerals in a very general way are important. So almost everything we surround ourselves with, we've dug up on the ground at some point in time, whether it is fancy metals that go into our wind turbines, or whether it's stuff that goes into our roads, into our houses, iron, steel, into mobility, and also into infrastructure. And you can see there's lots and lots. You're not supposed to read this, but there's actually lists of important things that go into things that we surround ourselves with. And even when we are in rooms like this one, where we can say, oh, here's wood, good old wood, this has been through a sawmill, clearly. And so metals and minerals are so fundamental in our livelihoods that is, of course, why we need to talk about them and why geologists need to be part of that conversation. If we zoom in on the energy transition, it could look something like this. And so you have a cross-section of a part of the upper crust here. You have all the different energy technologies, the new energy technologies on there. We do not have oil and gas on it. It should probably be on here because it is going to be part of the transition, obviously, for quite some time. What we see on here is compressed air, hydrogen storage, CCS. We see offshore wind turbines. We see onshore wind turbines. We see deep geothermal, shallow geothermal, solar panels. Here's a minor quarry, probably, you know, getting lithium for the lithium ion battery. There's more CCS over here, putting it into basaltic rocks or ultramafic rocks, different than storing it into cavities over here. And then, of course, there's also the issue of what do we do with our radioactive waste. And so this is sort of back to this thing that every solution to every challenge in this energy transition starts with us being able to describe the subsurface. So it starts with us. It doesn't stop with us. We still need engineers and other smart people to take this to the next level. But until you actually understand what's in the subsurface, basically making a geological map or geological model of what does the subsurface look like right here and how can we utilize it, until we can do that, we can't do any of these things. And on top of that, we could put other geology stuff on there as well. I will focus in on the minerals today, but we could talk about groundwater, we could talk about hazards, we could talk about lots of different things in this sort of model. So critical metals, everyone's talking about them. What is it? What does it actually mean? And when I say everyone's talking about it, I literally mean everyone. It's you cannot open a newspaper or meet strangers at family parties who haven't heard about rare earths and things like that. And they know it's very important, but they don't actually necessarily know why. So what is criticality? Criticality is when something is both very important to us and there's a real supply risk. So that is a really important thing to remember when we talk about these things, because there is a tendency that it's used as synonymous with actually just meaning important. Oh, it's critical for good reasons. You'll hear statements like that. What does that even mean? Critical means that it's both really important and that there's a supply risk. And there can be lots of different reasons for that. It typically can take into account things like environmental and ethical issues, but it typically looks at things like production concentration, geopolitical issues, and it could also look at, of course, geological issues. And it's typically something that depends on who's asking. What's critical to me may not be critical to Ruth, and so forth. So we talk about this from a sector perspective, sometimes from a country perspective. Some people want to talk about from a global perspective, but then it becomes really complicated because what is critical to us is not necessarily critical to China, and China might actually have quite a big role to play in why things are critical for us. But still, it is something we can talk about from many different perspectives. And when we talk specifically about the energy transition, there you saw all of the different sort of schematic technologies, and these are the different metals that go into them. And you have here about, I think there's 17 metals or minerals on this list here. I promised Mass to pull out graphite, it's right there. And then on top here, we have different energy technologies, including actually there's coal, there's gas. So there we have maybe a fuller picture of what actually is present in our energy mix right now. And you can see a colored square where a certain metal or mineral is important for that particular energy technology. And you can see again, let me point to graphite. Graphite is important in one of them, and it is energy storage. You can look at copper, which is right on top of it. Copper is important for every single energy technology, not surprisingly, because we need it to transport the energy from A to B. Another one that we talk about a lot these days is lithium, and just like graphite, you'll see that that's only actually in energy storage. This doesn't necessarily tell you how important it is or whether it's critical, but it tells you something about the technologies that needs metals and minerals. So if we look at a little bit at the demand side, how important is it that these things go into these technologies? This is the demand side. This is a World Bank study from 2018. So if we look at an outlook to 2050 of those same metals on here, now they're on the x-axis, and looking at how much do we need compared to what we need today, just for energy technologies, not for all the other stuff that we're already using it for. What's the predicted increase in demand? And you can see actually graphite and lithium are right up there at the very top. We need 500%. We need 5 times as much just 25 years down the road than we needed in 2018. And that is, of course, because yeah, they're only important in one energy technology and storage, but energy storage, just like copper for wires, is going to be important for everything that we actually do. So batteries is an important driver for increases in demand. But you can see many of the other ones as well are seeing very dramatic predicted increases in demand as we go forward. So as a society, and I will go a little bit UK focused in a bit, but in general, how can we think about this? How are we going to secure all these metals for the energy transition and potentially for all the other stuff that we want, like the roads and the cars and the buildings? What are we going to do to get them? And we pretty much have 3 basic choices. We can manage without them. You'll hear that a lot. We'll just do better, more sustainable, and use more responsibly. And that's a great solution to many issues. And then, of course, you have recycling and circular economy. That's also something you hear a lot. That why mine when you can just recycle? And we have all lots of stuff at home in our drawers. And then, of course, there is mining. We can dig things out of the ground. And I'll just very briefly touch on each of those 3, and then say a little bit about what the UK thinks they're going to do about this. Can we manage without minerals for clean energy? If you look globally, and then we do need to look globally when we talk about these things, because impact is global. And can we manage without it? Well, if you look globally, 940 million people, that's 13% of the world population, do not have access to electricity. 3 billion people, that's 40% of the population on this earth, do not have access to clean fuels for cooking. That means they're cooking over an open fire. That is not a particularly healthy thing to be doing. Per capita electricity consumption varies more than 100-fold across the world, and the energy consumption varies more than 10-fold across the countries. And not shockingly surprising, this tends to correlate with, it says here, poorer households, but let's be honest, it's countries we're talking about here. It's regions where people are poor and they're cooking over open fires, while we are talking about how we can reduce our energy footprint. So can we just do without these minerals for the clean energy? Can we just say we're not going to get all this new clean energy? We don't really need it. We can't really take that position if we're serious about this. And we are actually serious about this. We've committed to this, us along with pretty much everyone else. And so if we are serious about many of these, and I just at random circled some of them, no poverty, good health and well-being, reduced inequalities, affordable clean energy, climate action, and also the gender equality, and know who the 3 billion cooking over an open fire are. If we're serious about all of this stuff, we need more energy. Globally, we need more energy. We may all have a good hard look at what we do at home and what car we're driving, that sort of thing, and see if we can do better. And we absolutely should. But when you look at the global picture, we need more energy, not less energy. So let's turn to recycling or circular economy, because that's not a very popular option. And this article came out not 2 days ago, as it says here. I did a screenshot right after it came out in May of last year on BBC News. And it was actually on the radio as well. I heard it on the radio and was very, very excited when I heard them talk about critical minerals and how we get access to it. And scientists say, and I was like, well, this is great. What scientists are they? And I have to be really careful here not to insult anyone, but it turns out they were chemists. They were chemists who had made a study, and there was a big story about it run in the BBC that basically said, mine e-waste, not the earth. And they say so because we are running out. It's not sustainable because the earth is actually running out of minerals. So instead we have to recycle. So is that the way to go? And if you Google circular economy, this is a fraction of the images that will come up on your screen. And I always like this because it is really kind of, note how almost all of them are green. And many of them are like completely circular. This, of course, is a very schematic and simple example. Some of them are a lot fancier, but still closed loops. And that's how we like to think about circular economy. And there's probably gazillion definitions of what the circular economy really mean. But if we just get simple about it, it means really to get things into the loop in a sustainable way, keep it there for as long as possible, and if you can, loop it back in. But really, really importantly, and this is of course where geologists come into it, even if you could close the loop completely, so you didn't need to put anything new into that loop at all, even if that was possible, and it could theoretically be possible if you had a decrease in demand, then the things that you keep looping around still have been mined at some point in time. It still all started with a rock somewhere on some day. The reality, of course, is that we can think about this, and we should think about this, and we should try to close those loops. But the reality is, if you have an increase in demand, you cannot close the loop. And a very simple, very lame plot that shows this is that if you imagine you have an 8% annual increase in demand of something. That's a big increase, but it's not unrealistic when you look at these energy transition metals. If you are looking at 8% annual increase and you can recycle, you can extract every atom of every metal in the thing that you want to recycle, then you follow the pink line where your x-axis is a delay before recycling in years. And what you can see here is that if you use your stuff for 1 year, and then you put it into recycling, you extract every atom, but your demand has gone up by 8%. It will cover 92%. This is not rocket science. If you wait 2 years with recycling, that goes down, and it continues to go down the longer you wait with recycling it. And if you cannot actually extract 100% of the metals, if you can only extract 70% or 40% or 10%, it is less that you can actually cover in terms of your demand. And a lot of questions, or a lot of people will ask the question, but why does how many years I use it? Why is that actually important? I mean, it's important for a couple of different reasons. It's important because as long as I'm driving my car, you can't recycle it. And that's just a fact. But the other thing is that we all know we have stuff at home. Some of us perhaps have more cars than we need. We have old cell phones lying around in our drawers. We've all sorts of old gadget stereos from the 70s, all that kind of stuff. We all have it in our garages, in our cupboards. Why don't we just all bring that out? Because then we'll really have a lot. And that's true. We could bring all of that out, and it's possible it would cover our demand increase next year, and maybe even the year after that, and the year after that. But then the drawers are empty. and the garages are empty. So if we use more than 1 year's worth of consumption in a year of recycling, we are cannibalizing our stock. And it's actually not sustainable. We're making recycling unsustainable if we recycle more than what we consume in a given year. But this is a really important thing that many, many times gets overlooked. So yes, we can recycle more, and we should recycle more. Some metals we're really good at recycling already, but we cannot recycle ourselves out of a 500% increase in demand. Not possible. So we have to turn to this stuff, not generally liked a lot by the public. It looks like this. There's a nice yellow patch on there. There's a couple actually even in the background. So a nice color back there somewhere. But other than that, it's brown, it's black, it's dirty, it's dusty. Mining has an enormous history and legacy of doing pretty bad stuff in a lot of different places. And we can't escape that. And we shouldn't. We should own that, absolutely. But we do need to talk about mining. And that's the adult thing to do. And that's where geologists become very important people, because in these kinds of discussions, we are many times actually the ones that bring that to the discussion. And so, of course, are we running out? It's the big question. Is this actually going to be a problem for us because we're running out, like the chemists saying? Well, this is a map from the USGS. It's from March 2023. This is continuously updated. Anyone can go in at any point in time and do any map with any interesting metal that you like and see what are the deposits and the occurrences you have around the world. There's of course there's no grading of these. Many of these will be uneconomic today for sure, but these are the deposits that we know are there. So no, we're not actually geologically running out. So we do need to look harder at mining and think about how we can do that. And a couple of facts on mining that I always think is sort of a little bit mind-blowing that I want to just bring in here is this is data on everything that's mined in the entire world, all the metals that we're mining everywhere on the globe as we can best measure it. And it's actually, this column is everything that's mined. And it's almost all iron. Almost everything we mine is iron. It's a little bit, well, so 10% or something like that, that we mine that isn't iron. So what is that? Well, let's blow that up and have a look at it. This is what we're mining that isn't iron. There's some aluminium, there's some manganese, there's some chromium, there's some copper, there's a bunch of other stuff. And then up here we have the technology and precious metals. So these are actually some of the metals that we will need for the energy transition. So let's look at that little rectangle there and blow that up and see what that looks like. Well, there's a little bit of magnesium and molybdenum here, the rare earths, for example, some cobalt, vanadium, lithium, PGMs, other stuff there. So these things that we're talking about, where we're seeing a 500% increase in demand, that's sitting over here. So you hear people sort of say, oh, but you know, the thing about the energy transition is we're going to need so much more mining. It's going to be crazy. We do need much more mining of lithium, but we don't. It's kind of going to disappear in the big picture of things in that sense. That doesn't mean we shouldn't do it right, but it's just important to remember here what it is we're talking about. We're not talking about a mine at every street corner. We're talking about an increase in certain metals that are right now quite small. And that's actually maybe one of the problems. And I'll return a little bit to why metals become critical. But a really interesting thing is that when you can mine stuff that lots being mined of, generally, as a mining company, you're much more interested in that, in complicated stuff. Rare earth elements, terribly complicated to mine. Offtake agreements. It's really complex what happens after you actually dig it out of the ground. There's no rule that says it just because something is over on this side, it's not financially important or investors aren't interested in it. Because, for example, if you look at gold, that tiny little green rectangle that's sitting up there, rough estimate, half of everything that gets invested into looking for metals, exploration, half of everything gets invested into mining of metals, invested into gold. So there's absolutely no rule that because you're sitting in this column, people aren't interested in investing. It doesn't have anything to do with that. And whatever it has to do with is probably not for geologists to necessarily know about, but certainly something to worry about. Another figure that I just want to show, because I want to turn a little bit UK centric here, you know, what does it look like for the UK? But quite interestingly, these are quite new data from our minerals yearbook. And now this last figure was just metals. Now we're including everything we dig out of the ground, the sand and the gravel that goes under the roads and into our concrete as well. And look at this, and actually also energy minerals, which includes oil and gas. So what do we have in terms of production here in tons? Energy is this portion here. Construction is that portion there. Industrial minerals is that blue there. And then there's another blue that has almost the same color, but it doesn't really matter because it's 0% and it's sitting in there. There's almost no metal mining in the UK as it looks right now. And if you look at the value, something very strange happened to the slide. I don't know what happened there. All right. Anyway, it's the same legend, but I can also see that the 0% fell off here. This is actually in terms of value. So here you can see again now oil and gas and the energy is all of a sudden the big one, because in terms of the value of it, that is more important. Industrial minerals, no, a little bit more inexpensive. But again, you see industrial minerals, and then you actually have in here something like 0.01% or something like that, which is the value of metal mining. So what are we going to do in the UK? What we're going to do about the minerals and how are we going to get them? And so we're going to do probably a little bit of everything. We're going to do some resource management. We're going to be more sustainable. We're going to do some recycling and circular economy. We are going to support some mining. And we are also actually committed to understanding resources in a better way, all the way from geology to the supply chain and the investments into it. And I'll briefly just go through the UK mineral strategy, because that came out last year. And it was published on the 22nd of July, as you can see. And it basically sort of had three elements. It was following up on three elements from the roadmap to net zero that was published the year before, that basically sort of says, we will, in the UK, will develop a mineral strategy, and we will have an expert group that's going to help us do that. We will make a list of minerals that we think are critical to the UK. So again, having that importance, supply risk analysis done for the UK. And we will open a minerals intelligence center. And the first thing that happened was the list of critical minerals. And I'm not actually going to give you the list because you can look it up online, and it's not very surprising. It has got lithium and rare earths and cobalt on it, just like any other list of critical minerals that you'll find from anywhere in the world. But the methodology we used, we did this at BGS, and the methodology we used is that we used these sort of 6 parameters to look at how important is it for the UK. So that's that one axis in the diagram. How important is it really to our economy? And the reason I showed those figures before is, again, when you actually look at what's important for the UK economy right now is oil and gas and gravel, and not actually critical metals. But now we want to focus in and sort of say, what are we going to do about that specifically? And it's things like production evolution, price volatility, substitutability, global trade concentration, UK import reliance, and the gross value add to the UK economy. And they look at the supply risk. And this is sort of, again, it's the BGS methodology, but it's kind of building on the USGS methodology. And it has 3 things, 3 parameters. Production concentration. So what that of course means is it all being mined in China, or is it all being mined in another country, or is it something we can get from many different sources? Companion metal fraction, very important one, and recycling rate. And we use that to construct our list. And you're quite interesting, you'll see, geological availability is actually not on here, a little bit in tune with the map I showed you before, because as it turns out, there's some really important messages when you talk about critical minerals, and it is that critical minerals are critical for different reasons. So we can try to assess it, and we can try to come up with mitigations, but they are actually critical for different reasons. There's a few things that seem to sort of be a common thread, and one of them is that there's not one single metal on one single list anywhere in the world, critical minerals list, that's on there because of geological availability. So that's a very hard admission from a geologist, because we'd actually really like it to be about geological availability, because then we get some funding, we do some research, we can go look at some stuff, but it's not actually the problem. Geological availability, of course, is an important thing. We still need to understand the geological resources, but it's not what causes criticality. What seems to be another common thread is that it has to do with the market. And I showed you that figure before, where people investing. It seems to have to do with a true sort of market failure situation. For some reason, the market is not taking care of supply and demand. There's some kind of barrier to the supply and demand. It can be that it's, for example, it's a companion product. So the price of, or the feasibility of the mine is driven by the cost of a different commodity than the one that we're actually talking about. I'm done very soon. And so that is some important observations when we think about criticality. The UK Critical Mineral Strategy, it's a 10-point plan, and it's called ACE, and it stands for Accelerate, Enhance. And I forgot the E, but I'll get to the E. No, that was the Enhance. Accelerate, collaborate, and enhance. So accelerate the UK domestic capability. So this is what the government is committed to do. Maximize what we can actually get domestically, rebuild skills in mining and minerals. This is a really important one for this audience. This is something that we've lost, not just in the UK, but in Europe and in many other parts of the Western world. That's hopefully coming back. Carry out cutting-edge research and development to solve challenges in critical minerals and supply chains, and make better use of what we have by accelerating the circular economy. So all very good points, and all touching on those three items we had before. Collaborate, diversify supply, support UK companies to participate overseas, and develop our diplomatic relationships. And this is also very important, because even though we can take the UK-centric view of what's the problem to the UK and how we're going to solve it, we will not solve it if we do not solve this globally. So that is a very great thing to see in this strategy. And this one is related, but it's more about the markets again. What can we do to fix those broken markets? Well, we can try to boost global environmental, social, and governance practices, and that's certainly something that's high on many people's agenda. And it's a really good thing. Whether that's going to solve the problem or not, you can question, but it's certainly a good thing to be doing, and we should be doing it for all of the right reasons. Develop well-functioning and transparent markets through improved data and traceability. That's a really important one, really big one. Fair trade, palladium. A little bit like your coffee, but if it actually becomes something we all get interested in, not just as the end consumers, but the people who produce these things, if they have to certify that they have mined this sustainably and that they can recycle it when they're done with it, or when we are done with it, then we are a good step in the way. And then championing London as the world's capital for responsible finance is also a point. It's already been refreshed. It's a year old. And I'm not going to say much about this, but important in the refresh is actually that an independent task and finish group has been established. That's again directly supporting and advising government, but this time very specifically on the dependencies and vulnerabilities of the UK strategies, or the UK industries, sorry. And also there's been several sort of accelerated agreements internationally and instruments that have been identified to actually help us do research and get further with this. I'm just noticing how I spell instruments here. I do apologize for that. I got distracted. This is my last slide. The last thing that the UK is doing is that they have established, and this also happened last year, a UK Critical Minerals Intelligence Center. And this is really about, well, if it isn't geological availability, what is it? And who are really well positioned to understand it? And the answer, of course, is geologists. Even if it isn't geological availability, we do know our resources. We do understand flows and stocks. We can actually look at this as if it were a rock. This is a rock. If you want to recycle it, this is a rock, and you need to describe it the way that we're describing rock. We need to make a geological map, this, to be able to actually recycle it. So the UK Critical Mineral Centre is based at BGS, I'm proud to say, and it started last year. And the centre is basically taking a holistic approach to mapping the global critical mineral supply chains, tracking stocks and flow, and monitoring market dynamics, and understanding economic, geopolitical, environmental and ethical risks and opportunities. And there's already quite a few different products and reports that have come out. You can go onto the website and you can have a look at some of them. Just a couple of weeks ago, something came out on the domestic potential, just a quick look at what's actually the geological potential in the UK. And also a report came out on the defense industry and critical minerals and the UK in that context. And with that, I am going to say thank you and just show you a pretty picture of the East Greenland that I went to many, many years ago for the first time, and it changed my life. Thank you.